I remember it just like it was yesterday. It was a special place, filled with aviation history. My mom called it a museum, but it was really my dad's home office. Every square inch of the room reflected his passion for flight. For some reason, I often found myself here, surrounded by my father's things. If it had wings and an engine, he loved it. Even then, I knew I loved it too. I'm not sure when my dad's fascination with aviation began, but I think the Second World War had a lot to do with it. Growing up here near Atlantic City, he was just a kid in 1943 when the government built a naval air base on the site of the Pomona Airfield. They called it Naval Air Station Atlantic City. Winning the war would require training thousands of new pilots to fly all the planes coming off the assembly lines. A naval air station near Atlantic City would provide clear weather and open water, perfect for training flights. The Navy pilots who trained there went on to join the battle and helped win the war. My dad's enthusiasm for aviation would set his course in life and shape his entire career. I was fascinated by the work he did. I guess that's why I remember that day so clearly. I was going with him to work to see the place that he was always talking about. I guess it wasn't a coincidence, but my dad worked at the site where the Naval Air Station had been. You see, years after the war, the Navy decided to close the air station. At the same time, the federal government had begun looking for a place to build an aviation test center. This test center would work on finding new ways to make aviation safer and more efficient as more people turned to air travel as the fastest way to get from place to place. It would test new ideas and technologies to help the pilots who flew the planes. And it would explore better ways for air traffic controllers to safely guide all these airplanes to their destinations. It was 1958 when Congress created the Federal Aviation Agency, the FAA, and the National Aviation Facilities Experimental Center. The center, which everyone called NAFEC, was to be the research, test, and experimental center for the FAA. My dad had worked at NAFEC from the beginning. He was an engineer and a real roll-up-your-sleeves kind of guy who believed you could solve any challenge by bringing together the best minds, the right resources, and a can-do attitude. It was people like him who made the Experimental Center the place for testing and verifying the procedures and technologies that would shape the future of aviation. I remember my dad talking about all kinds of important projects going on in the early years. Things like one of the first laboratories where aircraft were electronically simulated on radar scopes to help solve air traffic problems. A data processing center where researchers adapted these new things called computers to assist in civilian air traffic control. The first test to show how moving aircraft create a disturbance in the air called wake turbulence. Firefighting and passenger rescue tests to help keep air travelers safe. And the Slush Project, where a jet plane taxied through a 1,000-foot-long blanket of slush. These tests helped determine under what conditions aircraft could safely take off if the runway hadn't been plowed clear. FAA researchers would work on aviation problems like these and conduct test after test until they came up with the right answers. I don't think I'll ever forget that drive. My dad explained how important it was that the best thinkers and doers, people dedicated to solving the challenges of aviation, could come together in one place to work on air traffic control, communications, navigation, airports, and aircraft safety. He couldn't have known it then, but the work he and his colleagues started was only the beginning. As more Americans took to the skies throughout the 1960s and 70s, the importance of the work being done by the FAA and the Experimental Center increased. The first mock-up life-size model of a tower cab was constructed to help controllers and airport planners get the feel of a new control tower before building it. Researchers at the center also developed a console to help airport controllers see the radar position of arriving and departing aircraft. There were tests on the development of less flammable fuels. Researchers knew that liquid fuel under pressure would vaporize. A single spark could turn this mist into a ball of fire. A less combustible fuel could save lives. Short takeoff and landing airplanes, also known as STOL planes, were seen at NAFEC during those years. These aircraft use very short runways, and the FAA conducted tests here on these special planes. My dad would continue to play an important role in the years ahead. He was proud of the work he was doing, and he was sure that the Experimental Center would play an even bigger role in commercial aviation as the future unfolded. It turned out he was right. In 1980, the Experimental Center became the Federal Aviation Administration Technical Center, now called the William J. Hughes Technical Center. The Technical Center continued to grow as the FAA's National Scientific Test Center for the modernization of the country's air transportation system. The 1980s saw the testing of systems to automatically help controllers track aircraft flying over the oceans, research into weather detection systems to see inside storms that might potentially affect aircraft, and the complex analysis that led to the creation of more air traffic routes and reduced separation between aircraft. This breakthrough made it possible to expand the number of highways in the sky and allowed more aircraft to use these routes efficiently. During the 1990s, the center built the Human Factors Laboratory to study ways to improve systems to make them easier for people to use. The Aviation Security Laboratory also came online to research technologies that could better detect explosives and weapons to help improve aviation security. The testing of a soft ground arrestor system paved the way to a method for stopping aircraft that might accidentally overrun the end of a runway. This technology is saving lives at airports across the country. A collision avoidance system relies on software tested and improved at the Technical Center. No mid-air collisions between scheduled airliners have occurred in the U.S. since the airlines were required to equip their planes with this technology. The world's first full-scale airport pavement test facility, built in partnership with the Boeing Company, made it possible to test new designs and materials for improved airport pavements. In every area of aviation research, development, and testing, the Technical Center has played a crucial role. When I look back at its modest beginnings, it's hard to imagine that the Technical Center has, in the 21st century, become the place for developing and testing the technologies that have made air transportation the safest way to travel. The men and women who work here today are a lot like the people who came here in the early years. They're researchers, engineers, scientists, technicians, specialists, and support staff, focused on the transformation of commercial aviation. Their efforts continue to shape the technologies of flight. Today's Technical Center houses virtually the entire National Airspace System in a laboratory setting. This enables research into every aspect of aviation technology. Researchers can test proposed improvements to procedures or systems before putting them to work in the real world. Tools that help predict, detect, and display hazardous weather are among the many FAA programs in which the center is involved. These tools help controllers safely manage air traffic as weather conditions change. Using information from satellites, pilots will broadcast their position and be able to see the air traffic around them. The center's human factors researchers are working on the displays and procedures to use this information so that pilots can maintain a safe distance from other aircraft. The Technical Center is home to the most extensive civil aircraft fire testing facilities in the world. Almost every improvement in aircraft fire safety over the past 30 years has resulted from the work done here by the FAA, including testing of an inerting system to prevent fuel tank explosions. A fleet of flying laboratories provides researchers with the ability to take to the air. New concepts, procedures, and equipment can be tested and evaluated on the taxiways, runways, and in flight. The maintenance of the National Airspace System is the responsibility of hundreds of engineers and computer specialists based at the center. They travel to FAA operational facilities anywhere at any time to ensure that critical systems are working perfectly. The Technical Center has also become a focal point for Homeland Security. The Federal Air Marshal Service has its training facilities at the center and provides an enhanced level of protection for the flying public. The Transportation Security Laboratory is the government's leading test and evaluation facility for new airport security technology. That's here too. In addition, the Technical Center is home to the United States Coast Guard Group Air Station, Atlantic City. The Coast Guard protects the country in every maritime region. The New Jersey Air National Guard 177th Fighter Wing is also located here. Among its missions is to provide personnel, aircraft, and equipment in support of the U.S. Air Force. When I went to work with my dad on that day, long ago, I realized that his job was all about the future. And when I think about it now, the work of the FAA and the Technical Center has always been about the future, making air travel better and safer for today and tomorrow. With aviation now in its second century, the FAA continues to focus on the evolution of the National Air Transportation System. It's a system that must meet the challenges posed by ever-growing numbers of passengers. The Technical Center will help to meet that challenge by testing the technologies and procedures that will open up the skies to more aircraft. Allow them to navigate with increased precision, fly with reduced separation, travel the most fuel-efficient routes while minimizing environmental impacts, and provide new levels of security and safety. It's a future where the air traffic system will become an increasingly collaborative, intelligent network, enabling each aircraft and every component in the system to communicate seamlessly. It's a transformation that must take place if we are to meet the demands of a system that will continue to grow. I think I must have known back then that I would come to work at the Technical Center myself one day. Going to work with your father can open your eyes to all sorts of possibilities. I guess that's why I had to smile when my daughter was excited to come along and see where I work. I don't know if she'll follow in my footsteps the way I followed my dad's. Who knows? I bet she'll make a great engineer herself someday.